Hello friends, this video on Light Part 7 is brought to you by examfear.com. No more fear from exam. So now the most interesting part, how is our image formed in the mirror? So now we exactly want to know that how that big image of ours happens, how this entire thing exactly happens. Let us look at the basic concept once again. So if this is your object, let us assume that the object is a point object. We are considering one point as an object. So rays of light from this object will fall on the mirror. So all the red colored rays which you are seeing, they are the incident rays. So you see bunch of incident rays falling on the mirror. As soon as they fall on the mirror, they will get reflected. And in which direction they will get reflected? So that is determined by angle of incidence and angle of reflection. So let me try to draw the normal. So that will give you a better idea. So the normal to the mirror, this is the mirror, so perpendicular to the mirror is this line. So now you see for this object, this is the incident ray, so this is going to be the angle of incidence. Now we know angle of incidence is equal to angle of reflection. So the reflected ray will be in this direction. Now the same thing is true for all of these. So therefore this is how the reflected rays will be after the reflection. Now do you think that these reflected rays will meet anywhere in reality? Anywhere on this side? No. So if you if you try to draw them on the other side, you see that they all tend to converge at this point. So therefore image is formed at this point. So this is how we see that. And any object will have an image formed on the other side of the mirror such that the distance of the object from the mirror and the distance of the image from the mirror is exactly equal. So if this distance is d, then this distance is also d. So the image will form exactly similar to the object, same size, and it will be formed at the same distance from the mirror as the object is from the mirror. Right? Now this simple concept is applicable for image formation for any object of any shape. So here if you consider human beings, so here also you can consider that each part of our body is nothing but a point object. So that is how the image is formed on the other side. So let us suppose if you consider this point, so from this point the incident rays are coming like this. All the red colored lines are incident rays and the green ones are the reflected rays. So these reflected rays when joined together forms the image here. So point wise the images are formed of the object, and as a result you get your entire image like this. So now you know how do you see yourself in the mirror, correct? So now the question is, we see so many different sizes of mirror, right? Now, do you think that you are able to get a full size image of yours in all the mirrors? If the mirror is very small, do you get a full size image of yours? No. So how tall a mirror should be so that you can see a full size image of yours? That could be an interesting question, right? Now look at this picture. So if you see here, how do you see your image? We see it with the help of our eyes. And how do our eyes see it? When the light reflected or when the reflected rays reach our eyes, we are able to see that object. Now, if the reflected rays from that object doesn't reach our eyes, then we do not see that object. That is the simple funda, right? So in this case also, if you see, for this is my object, this is the image. But from this image, this is the reflected ray, correct? Similarly, here also for this image, this is the reflected ray. So these two rays reach our eye in this way. So basically from here, you can see the feet of the image like this. So basically you need only this much portion of the mirror. So if you have only this much portion of the mirror, you will be able to see your full size image. So in order to view your image, only this much portion of the mirror is required. So that is why you would have seen that the mirror in which you actually see your full size image, the mirror is not as tall as you are because that is not needed. So look at this picture. So this is your object, this is the incident ray. This ray gets reflected like this and reaches your eyes, correct? Similarly, here this is the incident ray And how will be the reflected ray? The reflected ray will also be in this direction only, because angle of incidence is equal to angle of reflection. So the same line will be a reflected ray. And these two reflected rays, if you extend back, what do you see? So you can actually see it from your eyes to the entire height of this person. So basically this much portion of the mirror helps you to see it. Now what would happen if the mirror is smaller than this? So basically we can say that the mirror has to be half the length of your height. So whatever is your height, half of that should be the minimum size of the mirror to see a full size image of yours. Now what would happen if the mirror is smaller than that size? If the mirror is say 1/4 of your height, in that case what will happen? So as you can see here, in that case this is how the incident rays will come, but the reflected rays will go like this. So a lot of reflected rays will actually not reach your eyes. If the reflected rays are not reaching your eyes, you will not be able to see that particular image. In this case, all the reflected rays were reaching your eyes, correct? But in this case, the reflected rays are not reaching your eyes, and that is why you will not be able to see the full size image. So as you can see from the bottom part here, so somewhere here would be the normal. So when this is your angle of incidence for this incident ray, so this is how it will get reflected. So it is not reaching your eyes, so you will not be able to see the bottom part. So that this is how we decide how much should be the height of the mirror. So we say that mirror height should be approximately half the height of the person to see a full size image, or to see the full height of the image. So I hope this is clear. So the only concept is that only if the reflected rays reach our eyes, we will be able to see that particular thing. So in this case, what are we trying to see? We are trying to see this, our mirror image. Now, in first case, all the reflected rays from top to bottom, all of them are reaching our eyes. So we are able to see. In the last case, the bottom part, the reflected rays of the bottom part is not reaching our eyes, so we are not able to see the bottom part of the image. So it is a very simple thing. So based on whatever we have discussed so far, what can we tell about the type of image which is formed by a plane mirror? So some of the characteristics are, the image is always virtual because the reflected rays never really meet. They appear to meet. So how do we make them meet? We actually make them meet behind the mirror by extrapolating the lines. But the image is always erect. That is well proved, because when you stand in front of the mirror, do you see an inverted image of yours? No. So the image is always erect. Same size as that of the object. It is neither small nor magnified. Image is formed behind the mirror. So if object is on this side, the image is always on the other side. Distance of image behind mirror is same as distance of object from mirror. So this distance and this distance is always equal. So these are some of the characteristics of the image formed by a plane mirror. Thank you. Please visit www.examfear.com to watch more educational videos with a better experience. Please do not forget to like and subscribe to our YouTube channel for latest updates. Thank you once again.